Hi, Sir.
Hi, Amy. How are you doing?
I'm all right, thank you. How are you?
Very good, very good. So we started with binomial theorem. How do you find this particular unit?
Yeah, very interesting for starters, because it's like continuous. Like every time we get to a point, there's always way more to learn than what we've learned, obviously, even if it took so long. So yeah, it's always developing into interesting
That's
things.
that's true. And you'll soon realize that even next year in your year 13, there'll be a lot more of binomial theorem and its applications. So we'll
Yeah.
look into, as on date, we are actually looking into a restricted portion of binomial theorem where the index n is a natural number. Rather, I should say between non-negative integer, which is between 0 and n. And the value of
hmm
r is also between 0 and n, right? So it is all natural numbers, basically. I should say the whole numbers. So, so till now, whatever we are doing in binomial theorem is non-negative integers. So n is from 0 to any value, and r is less than or equal to n, but greater than or equal to 0. So both these numbers are actually non-negative integers. Soon you will see that the n value can be made negative or even a rational number. So that will be an extension next year, which will explore more. However,
hmm
binomial theorem, as you have seen already, has so many other applications, and combined with the Pascal's triangle, which we saw earlier, it is really very interesting to work with series. So till date, we have seen how to expand binomials, basically. And
hmm
now, today, we'll focus on the terms of which are there in the binomial theorem. So we'll see how each and every term can be identified, how we can figure out how many terms are there, and how to work with these terms and the binomial or even the polynomial in general. Okay.
Yeah.
So let me share the screen with you. This is the lesson for you today. So we'll talk about many things which will include, of course, I should begin with this binomial expansion, which is a plus b to the power of n. As you see, we write this as n choose 0. I'll say nc0 most of the time, times a to the power of n choose 1, a to the power of n minus 1b, n choose 2, a to the power of n minus 2b square, and so on. And the last term will be n choose n, b to the power of n. So as you can see from here, in a binomial expansion, if n is 10, the number of terms will be 11, right? One more, because it
Yeah.
starts with 0. Do you see that? It starts with 0, right?
hmm
And it ends with n. And definitely, when you do so, the number of terms will be n plus 1, correct? So it has one more than n. And a plus b whole square is a square plus 2ab plus b square. Three terms when n is 2, correct?
hmm
So it makes sense. But our focus today is on term number, and here we have term number. We normally write term number with T and subscript R plus 1, where R is that n choose R. This is the R which we are referring to, right? How many do we have to choose from all n, right? And you will now notice that the very first term is what for you? This is your first term, correct? The first term has R value of 0, correct? R is
hmm
0 in the first term in
Yeah.
NCR, right? And the second term, this is your second term, correct? And the second term, R value is 1. So in general, you will see there are n plus 1 terms, right? And the R value in this case is equals to n, right? So that makes sense. So we write term number as TR plus 1, right? So if I say fifth term, right? So if I say fifth term, then we have to look for NC4. Do you understand? So if I say fifth term, so we are looking for a coefficient which is NC4. That will be my fifth term, right? So you can see fifth term is T5, which will be equal to basically T4 plus 1. Do you see how? We'll get to the NC4 because R value is 4. Is that clear?
hmm Yeah.
In the series, we are always referring to the binomial coefficient n choose R, and therefore these term numbers are normally defined in terms of R, and so it is standard to write TR term number rth term will be
Mm-hmm.
actually tr plus 1, so that r gives you ncr value. So that should be very clear because this is the base for our lesson today. Okay.
All right. Okay.
Actually, every question will deal with only this tr plus 1, and so you'll really understand this term very well. And you see here coefficients a and b, right? So a plus b to the power of n. A, the index, the power here exponent is n minus r, and r is actually the power of b, right? B to the
Mm-hmm.
exponent of r. So that relates this r to the second term in this particular a plus b sequence. Is that clear to you?
Yeah.
Right. So that is way of writing a binomial theorem, right? Now, today what we are going to discuss is very first thing is number of terms. It may look very simple, as we have just seen a plus b to the power of 10, there should be 11 terms, right? But
Yeah.
I'll show you the examination style questions, which could be so tricky, right? Number of terms itself could be a very challenging question at times, right? Many students think it is the simplest question, but when you go through the examples, you'll understand how tricky it could be, right?
All right.
Then we will also see how to determine a given term, right? Well, the fifth term, just as I was saying, means you have to choose and choose 4, right? R
Mm-hmm.
value should be 4. That sometimes a mistake happens, right? It may be very expensive. Find coefficient of the index. So when I say, what is the coefficient of a to the power of 3, b to the power of 2, when we have a plus b to the power of 5. So that n choose r is the coefficient in this particular case, which we may have to figure out.
Find.
Right.
Oh.
Yeah. And then when we say general term concepts, there will be many questions where we'll twist this general term in such a way that makes things very difficult for the students. And we'll see how to work with those difficult situations, right? Couple of examples I'm going to take on middle term. Now, middle term is very important. Like this whole series, it may have n value, which could be odd or even, right? Depending
Right.
on whether it is odd or even, we may have one middle term or we may have two middle terms. I mean, you understand, two middle
Mm-hmm.
term doesn't make sense, very confusing, but that's how we call, right?
So
It's
you don't
like,
find the middle of those two terms.
no, not a median kind of a middle, right? So
Uh,
the two terms in the middle, we say, right?
oh,
So
okay.
it's kind of confusing, but once we go through the examples and understand our nomenclature of binomial theorem and its
Mm-hmm.
understanding, it will be clear to you, right? So for
Okay.
example, if n is equals to 6, then definitely we have 7 terms, correct?
Yeah.
Now, if we have 7 terms, then we have 3 here and 3 there. And the seventh term in between, which is the fourth term, is the middle term, correct?
Right.
Well, that is true. But if we have n equals to 7, in that case, we have 8 terms, right?
Mm-hmm.
Now, in that situation, what happens? So if you have 8 terms, you have like 4 and 4, correct? Now, it's very difficult to define the middle term, so we just break this up. We say still let's have 3 and 3, and both fourth and fifth, we'll call them as our middle terms. You understand this part now, right?
Yeah.
So when we have an even power, 7, for example, then we have even odd, if we have even power, 6 as example, we have 7 terms, definitely one middle term, very clear. And the value, of course, as you can see here, is n plus 1 divided by 2 in that case, right? 7 plus 1 is 8, divided by 2 gives you 4, and that is your middle term. However, when we have an odd number as an exponent, we have even number of terms. And in
Mm-hmm.
this case, for example, if I have 7, 7 plus 1 is 8, we have got 8 terms now. Now there are 2 terms in the middle. The one is in fourth term. So you can see it will be now n plus 1 divided by 2, and the next one will be n plus 1 divided by 2 plus 1, fourth and fifth following it, correct?
Right.
So this is what you have to keep in mind when you talk about middle terms. So I have many different scenarios which could come in examination, and I've taken care of all of them. So with 4 examples, I think we'll be covering up this part.
Could
Then
I
we have,
ask a
pardon?
question? Sorry. Could I ask a question?
Yeah, ask if you have.
Um, so with the a plus b whole thing to the power of n,
Yes.
with a and b, does it matter which way round? Like, let's say you had a constant and then an x with, like, let's say 2 add 5x. Does
Yeah.
5x have to be b, or can it be a?
Oh, you could change
Matter.
it. you could change,
Okay.
right? You
Because
could,
when you sub it into that like equation, it's
yeah.
that.
You
Okay.
also remember see the NCR basically can be flipped is same as NC n minus R also. So there is a symmetry from both the sides.
Oh, right.
That
Okay.
symmetry makes it like perfectly matching up from both the sides in many situations,
Cool.
right? So
Hmm.
that also works. Many times in multiple choice questions, what happens is you're expecting NCR as your answer, but amongst the choice, NC n minus R is the answer. It becomes very confusing. So keep that in mind that NCR and NC n minus R are the same thing, right? Perfect. So, and then you swapping, now you understand swapping doesn't really
Mm.
make much difference, correct? Well, there are some important series like 1 plus x to the power of n. Let me just mess this up, right? We have one this series, and we also have a series which is x plus 1 to the power of n. You get this point, right? So
Right.
if I
Yeah.
write a series 1 plus x to the power of n, in that case, what I get is everything in the increasing order, correct? X powers are in increasing order, correct?
Yeah.
But if I write x plus 1 to the power of n, then I get a series which is in decreasing power of
Eh,
x. You get the idea.
yeah.
So that
Yeah.
makes it different. Sometimes the question is that you have to write the series in increasing or decreasing order. In that case, you should decide like how should I put a and b. So that could
Oh,
be a very
okay.
tricky. So you have a good point there. Just to begin with, excellent question. I mean, you're just coming to a very critical question in the very beginning, which we should be addressing.
So it just depends on the question, like you're saying. So if it
Yeah,
says ascending powers of x, make sure you sub in a or b as that
yeah.
ascending power of x.
Ascending power of x.
Got
Yeah,
it. Mhm.
perfect. So I think this is generally clear to you. Now we have very good challenging questions on remainder concept. So many times in binomial theorem, you will be like surprised how we can ask you a question whether 49 could be a factor of this particular polynomial, or what is the
Mm.
remainder when I divide by 49, right? So those kinds
Yeah.
of questions could be very tricky. So we'll take one of those kinds also, right?
Okay.
Let's move further. So what I did was that I've taken a part of your extended, I should say, level A in this particular case. So we'll also be looking at A plus B plus C to the power of n. So binomial means two terms, but we can always have trinomials and their powers, correct?
Mhm.
As you know, you could actually combine the two to expand, right? Now it becomes binomial, correct? If I combine B minus C, so it is A plus B minus C within bracket. So it becomes a binomial, right?
All right.
Again, use the same concept, expand, and then re-expand that B minus C and get more terms. But as you can see, that is very cumbersome, I mean, to work with and difficult to analyze. So we'll have a standard formula. We'll actually derive a formula to find total number of terms in this case also when we have a trinomial to the power of something n, right?
Oh, okay.
Formula is given to you here, and we'll see how we get to this formula, right? Now, as I was saying, we have seen a plus b to the power of n, but to make things very interesting, what we do is we do take a plus b to the power of n and a minus b to the power of n. They're like conjugates, correct? So if
Right.
you have a series with a plus b and a minus b, and if I add them, then alternate terms will cancel away, right?
Mm-hmm.
And if I subtract them, even then alternate terms will cancel away. It all depends. Sometimes the odd terms will cancel away, sometimes the even terms will cancel away.
Okay.
So
Yeah.
that is kind of another complexity which comes into play when we work with binomial theorem related questions. So if n is odd, so if n is odd, that means we have something power like 7, right? In that case, we have even number of terms, right? We got even number of terms. And now, there are two middle terms, correct? In that case,
All right.
alternate terms are negative when you do a minus b thing, correct? So when I do a minus b, odd powers of b will become negative.
Yeah.
Now, if n is odd, and when you are adding them or subtracting them, then in that case, the middle term both have n plus 1 divided by 2 terms in that case, because equal number cancels away.
Right.
But when you have
Oh.
even power, there's one extra term in the center, right? So
Mm-hmm.
that extra term may get cancelled, may not get cancelled, depending on that, correct?
Oh,
And therefore, the number of terms in that series, which is for even exponent, is
yeah.
when we are adding the series or we are subtracting the two series, right?
Oh,
Accordingly, in one series, we have one extra term where that middle term doesn't get cancelled away. So we have n divided by 2 plus 1 terms. And if we are subtracting, then we have half the terms. You get the idea.
okay. Yeah.
So this is another very important point which we need to consider moving forward.
Wait, does these like formulas, let's say, kind of, do they only work if they are conjugate?
Conjugates, yes, yes.
Yeah.
Because they
So
have to
if it
exactly
was,
cancel away. Yes, you're right. If
okay.
they're conjugates, a plus b and a minus b terms. You are right.
So if it was a plus b to the power of n and then just that same thing again plus,
Minus,
what
yeah.
would you do? No, not minus, just plus
Plus.
the plus again.
Yeah, then it is 2 times a plus b. I mean,
Yeah, that.
plus the same term, it is 2 times a plus b. Well, it could be something else. So that could be a different term altogether, right?
Okay, cool. Hmm.
Now, sometimes we also work with when the exponent is not just n but 2n, right? So even exponents. So we'll also see what happens to the middle term when the binomial is a plus x to the power of 2n, not just n, right? So then the series is going up to 2n plus 1 terms, right? So in that case, also we have a formula which we will see. So lot to understand today. So being it'll be a pretty long lecture, and I hope you'll be able to absorb all this just as you did the previous two. So are you ready for that, Emmy?
Yeah, let's do it.
Let's do it. So we'll begin with the very first example, which is supposed to be the easiest and the simplest. And let me ask you the question. Example number one. Find the number of terms in the following expansion, 1 over x minus x to the power of 15. How many terms will this expansion have?
16.
Very good. So one more than this. Now see what I've done. I have now taken sum of two conjugates. Do you see that?
Hmm.
Y plus square root of x to the power of 10 plus y minus square root of x to the power of 10. And now these are being added and they are conjugates and we have an even power. Now, do you remember? It's very difficult to remember. We just introduced you. You definitely know it's a different answer than 16, right?
Yeah.
Half of
It
them
was
definitely
that
cancel.
the n plus, no, n over 2, was it? Plus
Okay. So
1.
again, for your reference, because this is very important, critical
Oh,
question.
it's there.
So when n is even, let's remember, when n is even, which is the case here, right?
Yeah.
In that case, when you add them up, then one more than half are there as your answer. So half is 5, so we have 6 as your answer. Is that clear to you? So when n is even, which is the case here, n is 10, and when you add the terms, when you are adding the terms as shown here,
Oh,
in
yeah, yeah,
that
yeah.
case, the number of terms will be half of n plus 1, one additional term, right? So that happens mainly because there are two numbers in the center, right? Or
Right.
there's only one number in the center which may not get cancelled. One
Right.
time gets, one time doesn't get. So that is the whole thing, right? The second time, when we have this same equation but with a negative, in that case, how many terms will be there? It'll be
5.
5. This is exactly 5. We should be very clear about these formulas. And now we have another question which is saying the exponent is odd. In case the exponent is odd, it is half the number of terms. You have to add one, of course, because 9
Oh,
half doesn't make sense, correct? Number of terms.
right.
It helps you to understand you have to add 10 and then divide it by 2 and you get 5 as your answer. Does it make sense to you now?
Yeah.
So
Okay.
once you understand the concept, it becomes a very simple question. Otherwise, there is a lot of scope of doing a mistake here.
Right. Okay. Yep.
Let me introduce you to question number two, which is actually a difficult question. Find the number of terms in the following expansion. All of a sudden, what you see here is not a binomial, but a trinomial. Do you see that? 1
Mm-hmm.
minus
Yeah.
2x plus x squared to the power of 10. And part B is x plus 2y minus z to the power of 9, and C is a plus b minus c to the power of n. So specifically, I have taken trinomials in example number 2. This is sometimes a very difficult question. Let me first get to the concept, the theory behind. Is that okay?
Okay. Yeah.
So we'll begin with the example here. We're taking a general term, a plus b minus c, which I wrote minus c. I should have written just plus c and shown you the example, but I wanted to provide you proof for part c also, right? So it could be plus or minus. What doesn't really matter. We are only counting the number of terms, right?
Mhm.
So a plus b minus c to the power of n, whenever that kind of a question is there, the method to do it is you club any two of them. So you have a binomial. So a plus b minus c has been clubbed to the power of n. And now you're going to apply the formula. nc0 a to the power of n, nc1 a to the power of n minus 1, and the second term to the power of 1, correct? B
Yep.
minus c to the power of 1. Next time, b minus c is squared,
Square.
and then it is cubed, and last time it is b minus c to the power of n. You see that?
Yeah.
So
Oh.
now we don't have that b to the power of n, we have binomial to the power of n.
Mm-hmm.
Now, let's see it another way. So in the first term actually gives you only one term, right? nc0 an, that is only one term. In the second term, I'm multiplying that a with b minus c, so I get two terms, right? Because
Right.
distributive property, I'll multiply and get two terms. So this gives me two terms, right?
Yeah.
Now I have a binomial, b minus c squared. When you expand binomial, you get three terms, right?
Three terms.
So
Mm-hmm.
we get three terms here. And likewise, in this series, the last will give you n plus one term, right?
Yeah, because you
Because
keep
that
adding on.
binomial is got power or index of n, and we
Mm-hmm.
have n plus 1 terms, and definitely that will result into n plus 1 terms. And so how many total terms do we have? 1 plus 2 plus 3 till n plus 1. So it's a
Mm.
natural sum of numbers from 1 to n plus 1, and the formula, is n plus 1 times n plus 2 divided by 2. You get the idea.
Oh, okay. Yeah.
That is the formula which you can use and answer your question. Do you see that? So that is how we will use the formula and answer. So can you answer? We'll start from here. N. So how many terms do you expect here?
Are you doing A?
We'll start with C.
Oh, C. Oh, so we're
There is a
doing,
reason. There is a reason. You'll see that. We'll start with
okay.
C. Yeah.
N plus 1 times
Times
n plus 2
divided by 2.
over
The sum
2.
of natural numbers till n plus 1. That is to be
Right.
remembered. Perfect. Now, when you apply this formula to B, it will be like what? 10 times 11 divided by 2, correct? 9 plus 1 is 10, 9 plus 2 is 11, correct?
Yeah.
55 in this particular case. Now, if you apply this formula to 10, then it'll be like what? 11 times 12 divided by 2, correct?
Right.
So we get 66 terms in that particular case. If you apply the formula, we get like this, right? Now, why I started in this fashion is the reason when I'm trying to explain you now. Okay,
Okay.
now see this. 1 minus 2x plus x squared actually is a perfect square. I could write this as 1 minus x whole square. Can I write?
Mm-hmm.
To the power of 10. I could write this as 1 minus x whole square to the power of 10, right?
Yeah.
Okay. Now
How did you get to that? Trial and error? Or you just know?
it's a perfect square. A square, b square, 2ab.
Oh, okay.
When you do fact, okay, so
I
fact.
can't just look at it and find out. I believe
You're right.
you though.
You're right. So it is not so easy to just figure it out. But I'm telling you, the examination style question on this particular topic, it could be so tricky. I mean, that is what we are coming. So we do have a general formula which works, right?
Mm-hmm.
But see how it works. Now we have a trinomial which can be factored. And basically, it is 1 minus x whole square. A square minus 2ab plus b square, right? This is 1 minus 2x plus x square. Is it clear to you?
Yeah.
To the power of 10. So see what happens now. I have 1 minus x whole square to the power of 10 means the power is 20. Now this binomial, 1 minus x to the power of 20, how many terms will this have?
21.
That is the right answer. So see,
Why does that say 66?
so we
That's
fix using the formula.
What?
we use the formula because we could not factor it, and then when we cannot factor, then the terms are not getting cancelled away or clubbed together. You understand the point? So there is a
Oh,
difference in the number of terms when it is a perfect square and when it is not a perfect square. To give you a clue, a plus b times a minus b is what? A square minus b square. We have
yeah,
only
because they cancel. Yeah.
we have only two terms, a square minus b square, right?
Oh, okay, yeah.
But if I have a plus b times a plus c, then what? Then we don't get two terms, right?
Yeah,
We get four terms.
right,
If I have a plus b times a plus 2b, then we have three terms. You get the
right. Yeah.
when you're multiplying polynomials, it is not necessary that you have the exactly the same number of terms. We are talking about the maximum number of terms. Some will get cancelled, clubbed together, and things like that. So you have to be careful in this particular way when you are answering such a question.
Oh,
You get the idea?
yeah. So you're saying only use that formula if it's a trinomial that can't be factored
Factor into a
yeah,
perfect square. So if it is
into a
not a
perfect square.
perfect square, right? So you have to
Yeah,
look for perfect square, a square, b square, and 2ab terms, right? If you
yeah.
identify that to be a perfect square, then simplify that as a binomial and then write down your answer. You get the idea.
Okay, yeah.
So
Okay,
that is
yeah.
the key. That is why I went into this. You can take this as a like a very important note.
So the note is only use this
Formula
only use this formula when the
is not a perfect square.
trinomial is not a perfect square.
Perfect. So basically, when you look at the trinomial, try to see whether it is a perfect square or not. If it is a
Okay.
perfect square, then they factor it and write down the answer, right? If it is not, then use the formula. So either way. So look for a perfect square in this case, right? So you find
Okay.
finding the number of terms could be so tricky, right? To begin with.
Yeah.
Yeah. But I hope this
When you
concept.
started, I was like, oh, this is easy, just n plus one. I got fooled.
Yes. Example number 3. Okay. In the expansion for 2x minus y to the power of 10, there is a term x to the power of k, y to the power of 4. Determine the value of k and determine the coefficient of x to the power of k times y to the power of 4. So, Amy, I think you can do this question. Can you try it out? How will you do this question?
Okay, so A, determine the value of k.
Yes,
So, yeah, so you just do 10 minus 4 because that's given in the question, and
correct.
then you get 6 as k.
That is correct. Yes. So now you know k. Now you need to find the coefficient for x to the power of 6 and y to the power of 4. So what is the coefficient when the term is 2x minus y to the power of 10? That's the binomial. How will you find the coefficient? Tell me.
Mm, so is that where you do the like n choose r thing?
Yes, yes.
Okay, so you do 10 choose, because we got y to the power of 4, so we
Yes.
10 choose 4.
Perfect.
Then you take the a, so that would be in this case 2x,
Correct.
and we found that to be to the power of k, which was 6.
Yes.
Then you just times y,
Y
oh
is
wait,
minus y.
minus y by 4 to the
Correct.
power of 4.
Correct. So the answer for coefficient will be 2 to the power of 6 times minus 1 to the power of 4 times 10 to the power of 4 as the coefficient for x to the power of 6, y to the power of 4. Correct?
Oh, okay. Yeah,
So
yeah.
remember, you have to multiply your coefficient with negative 1 to the power of 4, which is positive in this particular case in my example. But, the exponent could have been odd. Then you'll get negative answer also. Correct?
Right. Yep.
So be careful on this front. So that is also a very simple and a very standard question which will be always there in a test paper, okay?
Yep.
Example number 4 now, which is, can you please read the question and answer?
So, example 4, working with term number.
Yeah,
Determine the fifth term, T5, in the expansion x squared minus 1 over x to the power of 10.
correct. How will you do?
You would use that formula,
Yeah.
TR plus 1
Good job.
equals And
So,
choose
so we are
R.
saying T5 means TR plus 1, as you said. That means R should be 4.
Oh.
Correct? So NC4 we are looking at. Perfect. So once you identify this, then this question is not difficult at all, right? So, as you rightly said, you use this formula 4 plus 1. You got the value of R as 4. Since you know R is 4, we have 10 choose 4, x squared to the power of 6, which is 10 minus 4, 1 over x with a negative sign. Oh my God, I lost the negative sign in my typing. Negative sign. Thank God the power was even.
Yeah.
See, that is how we slip sometimes. It can really happen in a test paper also.
Hmm.
And I'm sure in test paper, if they give you minus in between the power, the exponent, will
Yeah.
God, I'm telling you, because they want to catch you on this, right? But my examples are much more simpler. So remember, you have to put this negative 1
Mhm.
over x to the power of 4. Fortunately, it was even power, so you did get positive answer. But you could get negative answer also. Is that clear to you?
Hmm. Yeah.
Correct. Is find coefficients once again. Find the
Okay.
coefficient of x to the power of 5 in the expansion of x minus 3 times 5x minus 1 to the power of 6. How will you do this?
Mhm. Uh, can we do it like last time or?
Yeah, it is similar to what you expanded last time, you remember? In the last exercises, you had done expansion of similar binomials, right? So, but
Yeah, I mean,
we are only focusing on the term, and we want which terms will have x to the power of 5. You can
I
add the.
only know a long method. I'll just expand the whole thing and then
Okay.
find the one that says x to the power of 5. But that would take so long.
Okay. Well, in a way, you will not be wrong, but we could save some time by
Mm,
thinking that when you expand 5x minus 1 to the power of 6, we are only interested in x to the power of 5. So we can
right.
expand because higher power is in the beginning. So first case will be to the power of 6, correct? And
Uh,
second term will be to the power of 5. The third term will be to the power of 4. Now, we need not go beyond this because we are
mhm.
multiplying by x minus 3. So when you multiply x with power of 4, you will get power of
Yeah,
5.
5.
So you have to expand till at least the first three terms.
Okay. Yeah.
So you may not do the full expansion, but definitely
Mhm.
these three are required. Since we have to go up to the power of 5 and we are multiplying by x minus 3, even x when multiplied by x to the power of 4 will give me x to the power of 5. So expand three terms. Is that clear to you?
Yeah.
So now you know how much to expand. So no extra time is wasted. Now, how do you get power of 5? One, when I multiply by a constant, a power of 5, I get power of 5. Second, when I multiply x to the power of 4 by x, I get power of 5. So these are the two terms which are going to give me power of 5. So
Hmm.
I will now combine these two terms. Minus 3 times, as I have written here, minus 3 times 6, choose 1, 5x to the power of 5 minus 1. So I have taken these two terms, correct? I have taken these two terms and
Hmm.
taken the very first term, correct? So that is the term which I have written. Now,
Hmm.
I have multiplied with x the second term, which is x to the power of 4, and I got my second term, which has x times x to the power of 4 gives me x to the power of 5. So I have two terms which have x to the power of 5 in it.
Right.
The coefficients can now be added because they are the like terms. So you add the coefficients and get your answer.
Mm.
Correct?
Yeah.
So that
That
is how.
makes sense.
That is how. So it's not very difficult once you understand the concept. So that is how it could be done. So in the test paper, this could be a quadratic equation. Do you understand? Then you may have to go for the third term because x squared times x cubed will give you power of 5.
Yeah. So you're looking for like kind of like pairs or things that would make that power of, let's say in this case, like 5.
Yes.
So a constant with something. Okay, yeah. Hmm.
Example 7. Find the sum of coefficients in the expansion of x squared plus 2x minus 3 to the power of 3. Now, I mean, can you read this question once?
Um, yeah.
Yeah, read.
So find the sum of coefficient in the expansion of x squared plus 2x minus 3 whole cubed.
Now, what does this mean? Sum of coefficients. What does that mean?
It means, so you have so many terms, right?
Yes,
And
yes.
then the coefficients in the beginning, you add
And
them all
C1
up.
and C2 and all those terms, which, right?
Yeah.
Those are the coefficients. Perfect. So we're excluding x. That means
Right. That's what I meant.
all those numbers which come, you have to add them all in the whole expansion of, and that too, I'm talking about a polynomial of a degree 3. And if it is not factorable, you know how many terms it has. 4 times 5 divided by 2. That means 10 terms, right?
Right.
For examination, it is a very difficult question, and sometimes if you just start expanding like did I? Oh yeah. So you'll see, I did it. So we clubbed the two terms and we had the third term and we expanded. Now, why I did it is mainly because this was our last exercise. Previously, we were focusing on expanding the binomial series, right? And learning
Mhm.
how to expand. And this is expanding a trinomial was a difficult question there. So I thought, let me why not share it this time, right? But our focus today is just to find the terms and the numbers, right? Not really
Right.
expanding. But anyway, if you have to expand, right? In that case, this is the way to expand. Just club any two terms. I clubbed these two, and then we kind of expanded, kept on doing all those things. And we got a result. And finally, we can always add the numbers and you get your answer, which came to be 0 in this case. Well, no, always it will not be so.
Mhm.
Now, I'll tell you a shortcut for this particular case, how to do this. Now, you remember, Amy, when we say 1 plus x to the power of n, what is the sum of the coefficients in this particular case? The sum of the coefficient is 2 to the power of n. Replace x with 1, right? And when
Okay.
you put x as 1, then all the x's become 1. And in the equation, there is only the coefficients. You see that?
Oh, yeah.
So,
Oh my God. What? That's crazy.
so anything, it doesn't matter. Even if I have, for example, if I have 2x plus 3 to the power of, let's say, 20, right? And now
Yeah.
sum of coefficients, then this expansion will either have constants or will have x's, correct?
Mhm.
And we have to add all of them. Why not put x equals to 1? And if I put x equals to 1, I get what? 2 plus 3, 5. And so my answer is 5 to the power of 20. Done. Sum of the coefficient is 5 to the power of 20 in this case.
Oh.
Well,
Oh.
I have to add everything, right? Except for those x's. Why not?
Yeah. Oh my God. Wait, so in the exam, will they ask a question like this?
Yes.
Is this a method they teach in the book?
No. They might.
So they would expect you to do all of that and then add them up at the end.
They might. Yes.
Oh my
And
God,
they
that's so
might
time
use the
wasting.
method.
What?
So now I don't have to do all this, but this I did just because we wanted to review also,
Yeah.
right? It's good practice. And also to make you understand that if you do this, you lose so much of time. Why not just put 1 here, right? So we get 1 plus 2 minus 3 to the power of 3. And what do I get? 0 to the power of 3, which is 0. Done. You get the idea.
That's really cool.
Then
Yeah.
whenever there is a question on sum of exponents,
Hmm.
that means they are adding all the numbers, but not the x's. Why not put x as 1, right? Because 1 times anything doesn't change.
Yeah. Yeah.
So we
Yeah.
get the right answer. Is that clear to you?
Perfect. Yeah.
Yeah. So difficult questions solved so easily. This time, another very tricky, a different type of equation altogether. Can you
Hmm.
read this question?
Yep. So example 11, rational terms. Find the number of rational terms in the expansion of square root 3 plus square, no,
Fourth power
fourth power
of
of
2,
2
everything to the power of
whole
100.
thing to the power of 100.
Now, this is another new term for you, rational terms. So, rational terms means, square root 3 and square root 2 are irrational numbers, correct? So,
Hmm.
whenever in the term we have irrational numbers, they will be treated as irrational terms. That is what we are trying to say when we say rational terms. Is that clear to you?
Oh, okay.
So
How come it's not irrational
yeah,
terms?
irrational terms. Rational terms will not have square root 2, square root 3, square root 6. They will not have those, right?
That's not confusing.
Yeah. So we
Okay.
want terms where we do not have square root 2 and square root 3 terms, basically. That's
Okay.
what we are looking for. Obviously, in the expansion, you multiply these terms so many times. And, square root 3 times square root 3, if you do, you get
3.
9, which is a rational number, right?
Wait, square root 3 times square root 3.
Will be 3, sorry, which is a rational number.
Oh, yeah. Okay.
Right. So, for example, yeah, that's what I meant. So there is a possibility of getting many rational terms because of all this, correct?
Yeah.
Many powers will have irrational terms also. So our interest here is to find the number of rational terms in this particular sequence, right? Now, let's start with the general term. And general term TR will be 100 CR
Mm-hmm.
square root 3, 100 minus R,
Mm-hmm.
and this to the power of R, right? So that is a general term. So let me write this as a general term. Yeah, right. So TR, because I've used TR in a different way also, we'll not mix it with the term number, okay?
Okay.
So that's a general formula for our term. So 100 CR and all this. So from here, if we want to simplify, we know this is rational, right? 100 CR is always rational. No problem with that part. But square root 3 to the power of 100 minus R could be written as 3 to the power of 100 minus R divided by 2, right?
Wait. What?
Square root 3
Yeah.
to the power of
R
100 minus R
minus.
is equals to
Yeah.
3 to the power of 100 minus R divided by 2, correct?
Because
That
square root is
square root
half.
is, yeah,
Yep.
half times that. Similarly, fourth root 2 to the power of 1 over 4 times R will be 2 to the power of R over 4. Is that clear?
Mm-hmm.
So that is what I have written in the next statement. So I just translated as exponents. So
Oh, okay.
that
Yeah.
radical sign and wrote this as this. Now, if we are looking for a rational term, clearly, what should be R? R should be multiple of 4, right?
All right.
Otherwise, it is not a rational number. So we should have multiple of 4 as the value of R between 0 and 100, correct? Because R is limited with 100, correct? So we
Wait,
know
how did you know it was 4? Sorry.
we have 2 to the power of R
R to the.
over 4. So if I want natural numbers, then R should be 0, 4, 8, 2. Otherwise, we'll have a
Yeah.
irrational
Got
number.
it.
Got the
Yeah.
concept, right?
Yeah.
R value is between 0 to 100, correct?
Right.
Because the index is 100. Now we have a condition from here that R should be a multiple of 4. And
Right.
since no R should be a multiple of 4, it could have these values 0, 4, 8, 12, 100, like that, right? All
Mm-hmm.
numbers. And how many of these numbers are there? You can count how many numbers are there. There are 26 numbers, and those 26 numbers will represent our rational terms in the sequence.
How do you count them? Do you just list them out on a piece of paper, or is there a quick way?
So this is 4, right? Divide 100 by 4, you get 25
25.
plus 0, another term. When you add
Oh,
both the
sweet.
elements, yeah, so
Uh-huh.
0 is additional, right? 4 times 1, 4 times 2, 3, 4, 25, and this is 0 plus 1, right? 26. So that's
Right.
also in objective type question. Sometimes at the end you may make a mistake. So there
Yeah.
are 26 rational terms in this particular case. Is that
I like that question. Yeah, it's
very
nice.
interesting? So I
Yeah.
think we'll close our lesson today at this point. And
Okay.
the next lesson will take up about the concept about how to find the middle term in many cases. Perfect. And we'll also revisit few questions which, I typed them wrong and we had a difficulty in understanding. We'll go through those questions also again in the next class, right?
Okay.
Okay.
Yep.
So can you summarize what did you learn today?
Yeah. So, first of all, for starters, yeah. So it was a lot of like these formulas and things, which we kind of obviously used all of them throughout the lecture. all for different uses and purposes. So I think, yeah, so especially with the trinomial one, which is the a plus b minus c all to the power of n,
Mhm.
that formula can only be used when the trinomial is not a perfect square.
Perfect.
Okay, so otherwise, you can use it, and it's really handy. You have to be like obviously aware that if n is odd, if you got an odd degree or an even degree, so odd degree means there would be an even number of terms,
Right.
so there would be two middle terms.
Right.
And then if you have an even degree, you'll have an odd number of terms, so you will only have one middle term.
Perfect.
Um, we haven't come on to middle term yet, but when we do, it's just good to be aware of those two concepts.
Perfect.
Then we did a lot of like new different things which I haven't heard of. So like, let's say we did a few questions on finding the coefficients.
Yes.
Yeah, I'll come back to that in 2 secs. Yeah, so finding the coefficients, there's different ways of doing it. So like in this one, what we did was, so the long method would be expanding the whole thing, but that's not necessary because we're only looking for the coefficient, in this case, x to the power of 5. So start by going down, like when expanding, start with 6, 5, 4, like that, and then you don't have to go all the way to 1 because they're only asking to the 5. So try and find pairs like we did in this case. So constant times x to the power of 5 would be an x to the power of 5 something.
Yes.
And then x times x to the power of 4 would be x to the power of 5. So those are the only two you need. Don't use any of the others because that takes too much time.
That's true.
Then we did look at the, was it the rational, the rational terms?
Rational.
Yeah, so this one, it looks really complicated, but actually it's quite like straightforward. I think it's just getting that first bit. So I think when you see rational or irrational like functions or terms or things, write them in like exponential to an exponential kind of form. So that's easier to work with. So like we did, root 3, write it as 3 to the power of a half, and then work from there. It's quite straightforward. And also we found a key thing when trying to find the possible values that r could be. When doing 100 divided by 4 is 25, don't forget to add 0. Otherwise,
I like
after all
that.
of that working, you'll be wrong.
That is so cool. So,
Yeah.
I mean, I think you got the gist of it, and it was a pretty long lecture, so we had to stop in between, and that's a good thing to do. There's a lot to digest now. So, I'd like you
Yeah.
to really practice some questions on your own. Get
Yeah.
to know these in a systematic way. We've skipped many steps, many places. Since
Okay. Yeah.
trying to give you an idea, overall picture of how to solve such questions. And that's the whole thing. So get
Yeah.
into the
Yeah.
details of getting it just perfectly fine from examination point of view. And next lesson we'll take those middle terms also because it is entirely a chapter in itself. As you have
Really?
just said, that there could
Oh.
be cases with even powers, odd powers, and negative, adding them, subtracting them, and so confusing at times. Why it just doubles up few terms and doesn't double up the others. So we did
Yeah.
take examples where there was doubling involved, right? So we'll
Yeah.
take it up in our next lesson. But I hope
All
you
right.
understood
Okay.
this part. Uh, did you really get it all?
Yeah, yeah, the bits that we went through up until the things, it was really clear and I understood it. Now I'm just going to do like what you said, go through a few practice questions, and I'm going to write every single step, because for me, if I like skip steps, I'm like, well, how did I get to that? So yeah, and if I have any problems,
Yeah.
I'll
I'll share
email
this
or
video
WhatsApp.
with you. So once you go through the video, you'll understand what we went through.
Okay,
And that
cool.
should help
Thank you.
you to really grasp the things which you missed. And then you'll be absolutely ready for the next lesson. Thanks a lot, Anil.
Sweet. Okay. Thank you so much, sir. Have a good rest of your day.
Thank you. And have a great day. Bye.
Thank you. Bye.